The reviewer, please start. Okay. Hello. I'm Ian from Miracle, and I'm the reviewer of Badminton in Spaghetti Accelerator. This is the problem recap, and they focus on what causes the phenomenon and what parameters affect the speed. And first, I want to talk about the report overview. And in the observation, they use a tube and find out the reason why the spaghetti break. And they also consider the fracture position. And they think it's in the middle of the spaghetti, which we agree with this. And their theory is about the geometrical restriction and the translation between potential energy and kinetic. And they think it's like 3-to-1. And they have shear waves. And at last, the experiments in conclusion, they use the Young's modulus to know with the spaghetti, and they use equipment to control the initial velocity, which I think they did a great job. And their parameters are about the length of initial spaghetti and the input angles and the diameters in the tube, and also the initial velocity. Then I want to talk about the pros of the reporters. First, they have a well observation, and the theories they gave us as well, and the experiment also fits the theory. And they also have done many parameters. The cons are they didn't manage time well, and they explain the experiment data, but there are not clear videos of the machine that they used to convey the spaghetti, and they didn't mention the limit of theory, and there are lack of data. Then it's overall opponent. The pros are they have good time management, and they detail overview like all of about the theory, the experiment, and also the data. And they point out some small mistakes the reporter have made, and they also give some good suggestions. And the theory work. And they also correct the wrong theory. And the cons is they didn't discuss the experiment further. So let's talk about key discussion. The opponent thinks that bending failure is different from fracture. Initial length. The opponent asked about the initial length, and the reporter said different lengths will cause different velocity. Then this is what I mentioned before. The opponent say that the reporter should mention the derivation with theory, but the reporter didn't mention it. They also talk about the energy loss. Let's talk about our question. I asked about the ratio of energy loss, but the opponent is not talking the same thing with me. And I also asked about the most important parameters. They think it's this, and they think it's also this. The first point is about the angle of input. The missing points are they do not have the radius of the tube.
So I guess we can stop here. So now the reporter will make the conclusion.
Okay, so now I'm going to do a conclusion remark. First, I am the opponent. We talk about the graph of the force, and I think we need to know that how the works the direction of the force is. And next is about the initial force. And I think that it's important to know how the initial force effect is. So I think it's a further research I can do. And now we talk about other things like boundary conditions. I think there are boundary conditions about. I talk about boundary conditions that the spaghetti cannot break into two same parts. But I failed to talk about how wide the spaghetti break goes through the tube. And I think it's important to do that. And next is about the energy loss. And I use the equation to prove that the energy loss of the series is fixed with the experiment. So I think the energy loss is very small, but the opponent cannot agree it. And I think but the suggestion of the opponent is very good. And I think it's good to calculate about the energy loss about it. And also the energy loss when the spaghetti breaks into two same parts. And thanks for worthy discussion. Thank you.
Since the reporter closed earlier, so now time goes to the jurors. Any questions? Okay, that's the Professor Yi.
I think the opponent will focus on the bending energy and the buckling effect. But when I see the data of the reporter, I think it's fit quite well. So how's the important about the bending energy? And please give some comment on the bending energy.
So of course I can see that they have fit the data well. However, that does not fit to every case of the insertion, as they have not considered like different insertion angles. They only consider the angle which bending will, of course, the bending will happen. So they only focus on the scenarios where the bending energy affects the most. So that's a little bit wrong with the perspective.
I think he mentioned the bending energy because he wants to get the boundary. But I think the main purpose in this question is to know the velocity of the debris. So I think that is not a big question.
Okay, I think that bending energy will affect the final velocity of the spaghetti, and the work will cause the bending energy. So we use the work and we use the bending energy to connect the work and the kinetic energy. So I think it's necessary to calculate about it.
Okay, so I guess Professor Bao is about it. So, okay, please.
Okay, I have some question for the reporter. Can you show your PowerPoint from page 19? So you have a different tube.
Yes.
Here, you use the same length of spaghetti and apply the same force. Which one will go to the five point?
Sorry, these tubes are, we push the spaghetti into a tube, the length L is the same. And these four tubes is about we push the spaghetti into the lengths are different. This is the length difference, and the length will be
No,
the same.
don't X this difference. The five point of the spaghetti. Which one?
I think according to my observation, is this one. This one. Okay, because
So
of
you have any data showing that one is inferior? So, okay, so how about opponent, do you agree?
Well, I don't think that the data is correct, since they control the inserting velocity, but not control the force of the.
Same source, same length of socket, pushing the different tube. Which one go to the size?
From my data or from
For your opinion, from you say it's the biggest one, how do you agree?
no, I don't agree. I think the smaller ones will have more conservation.
Sorry, can you say the question again?
Okay, can you show back to the page 9?
Page 19.
So, the photo has different tube. So my question is, to have the same length, so that, using, push the same force into the different tube. So which one?
Diameter of the tube.
Okay, now, my question is which one go to the files? The reporter say the biggest one, do you agree that?
The size point?
Further, okay, they have
Oh,
the
the
biggest,
further, okay. I think it's the smaller.
the smallest one. So,
sorry, can you explain your expression again? It's about the distance they.
okay, you have 4 tubes. You put the same spaghetti inside, then the spaghetti break, then they have the velocity to split out and ice. Which one give you the five? Then the 5 further. Which one?
Okay, I think it depends on inflection and in my data.
Okay.
Extra
I see,
10 minutes, 10
so
seconds.
After that.
This is about the biggest tube, and this is about the smallest tube. In my data, the velocity of the biggest tube is
So
based
this
on-
4 point, that's the 4 tube.
Yes.
So the biggest one is the
This one.
first one. Okay,
This is the
okay, thank you.
Thank you. So I think the time we have the juror will have to calculate the grade, and so let's wait for a minute. Someone breathe. All in good time. Be patient, all in good time. Can we go on or we have? Okay. So, if now that we have to give the grade to reporters. Okay, please show the board here. 7, 8, 7, 8, 6. So now we have to grade, issue grades to opponents. Sorry. Okay. Now there's 7, 8, 7, 8, and 7. Now finally for the reviewer, okay. Now the grades here is 6, 6, 7, 6, and 7. Any comment from the jurors, if any?
I say something. I think the reporter in the beginning you spend too much time talking about your theory. Okay, so I would suggest you give a conclusion. Okay, your theory will produce something, and your experiment match the theory, or you will say something about it. Okay, so that's why I give you very close.
Any other comments? If not, then that concludes our game this time. Okay, thank you very much. Now we are in recess.